Hello class. Today we're going to go over the statistics that we've reviewed throughout the semester. Now, of course, all of this should be a review from a statistics course, but in this class we really emphasize the types of designs and the statistical analysis that go with it. And that's what you're going to need to know going into your statistics assessment. We're going to start off with between subjects designs. So when we talk about a between subjects design, we're talking about at least two different groups. So you have a single factor, two group design. And here we can look at the mean difference of those two groups. We have one independent variable with only two levels, and we're comparing the means or the averages for those two groups of participants. So here, again, you see we have two separate groups of individuals. You can see that those different groups are color-coded differently, representing that they are two separate independent groups. We can compare the means and standard deviations. And so the appropriate statistical test for this would be an independent measures t-test. And this is only when we have an interval or ratio level of measurement. Now that's important because when you have nominal or ordinal level of measurement for your dependent variable, you can't compare a mean difference for those two groups. You can't get a mean difference for nominal or ordinal levels of measurement. Now, if you're not sure, you're not remembering what those different levels of measurement are from earlier in the semester, it's really important you go back and review that because that is important in helping you decide what type of statistical analysis will be done for the different types of designs. So when we have a nominal or ordinal dependent variable, we can compare the frequencies of the two groups of participants. And it's important that these groups be independent, so it doesn't work the same for within subjects variables. There are some exceptions, but keep in mind that you typically want those cells that you're comparing that frequency of to be separate groups of individuals, or at least be completely separate measurements. So when you have this frequency to compare, you often use a chi-square analysis, and you compare the frequency in each cell to the expected frequency. Now, moving on to when you have more than two groups of participants. So we're still talking about independent groups, separate groups between subjects design, still single factor with one independent variable. Here we're going back to the interval or ratio level of measurement. So we're going to go with your basic, just three separate groups, so it's more than two groups. So you can't do a t-test anymore. You can't do just that simple comparison of means. This could be more complicated. You could have 4 groups, you could have 5 groups, but we're just going to go with the basic 3-group design. They are, again, separate groups of participants in each condition. Again, because we have an interval or ratio level of measurement, we can compare those means and standard deviations. So we want to compare condition 1 with condition 2, condition 2 with condition 3, condition 1 with condition 3, and that can be analyzed with an independent measures analysis of variance. So note that this is different than the t-test that just looked at compared the means for 2 groups. When we have more than 2 groups, we need to use that ANOVA. Now going on to a between subjects design where we still have a multiple level design. We have more than 2 levels in our research design, but the data is collected on a nominal or ordinal level of measurement. So again, we can't compare the means for these 3 groups because we can't get a mean for a nominal or ordinal level of measurement. Here we're going to compare the frequencies of each group with the expected frequencies again. And this would be done most likely using a chi-square analysis. So now we're going to go on and discuss what happens or what type of statistics we do when we have a within subjects design. So now when you have a single factor or multiple treatment design, so again, you have just one independent variable, you have more than 2 levels, and the participants, this is within subjects, so the participants are going to participate in all 3 treatment conditions or all 3 levels of that independent variable. We're using an interval or ratio level of measurement. Again, one independent variable with more than 2 levels. This could be more complicated. Here we're just throwing 3 different conditions. You could have more. You could have 4 or 5, but we're just going to go with 3 here. And this group of participants is participating in all 3 conditions. And because you're using an interval or ratio level of measurement, you can compare means and standard deviations. So with this type of design, again, it's going to be ANOVA because we have more than 2 levels. So a t-test is used when you have 2 means to compare. And ANOVA is used when you have more than 2 means to compare. We're using a repeated measures ANOVA because the participants repeat the treatment condition and participate in all 3 levels. And hopefully you can distinguish that from an independent measures ANOVA where the groups of participants are separate and independent. Now we're going to talk about factorial designs. So you could have a between subjects factorial design where you have your two different levels of measurement, your two different factors. So here's social interaction is one factor with two levels, ostracism and inclusion. Group type is another factor, a second independent variable. You have in-group and out-group as your two different levels. And these are four different groups, separate independent participants in each cell here. That's different than a factorial design with a within subjects design. So here you have one group in all four cells. So you have marijuana use, they smoked marijuana or they had a placebo, and you have a task, difficult and easy. So these participants smoked marijuana, then did a difficult and an easy task. Then later on, they got a placebo and they did a difficult and easy task. So it's one group of participants participating in all of the different conditions. And with both of these, you would be doing a factorial ANOVA. So an interval or ratio dependent variable, it would be a factorial ANOVA. Note that that term factorial is different than independent measures or repeated measures ANOVA. This is a different, more complicated statistical analysis. This will tell you if you have a main effect for social interaction, a main effect for group type, and then an interaction between the two variables, and if those are statistically significant. Again, that factorial ANOVA will tell you if you have a main effect for marijuana use, a main effect for task, and if there's an interaction between marijuana use and task. Now, sometimes you have one factor or one independent variable that's between subjects and another factor that is within subjects. That would be a mixed design. So here you have a between subjects factor where you have one group of participants that played a contact sport, another group of participants that played a no contact sport, and then you measured cognition before the season and after the season. So this is one group of participants, this is a second group of participants. So this is your between subjects factor and this is your within subjects factor. And so you have a mixed design. Again, you would analyze that with a factorial ANOVA if you have an interval or ratio level of measurement. Now we're going to move on and talk about correlational research. And correlational research in particular when, again, you still have that interval or ratio level of measurement. For correlational research, and I really hope you all are understanding the difference now between correlational research and what a true experiment is. So here you have scores and each pair are identified as X and Y. So one individual gets at least two separate scores. You could have much more complicated correlational designs, and many of you have seen that in your research papers you've been reading. The data can be presented as a list showing the two scores for each individual. So here, this is A through N are different participants, and you can see they have a score for family income, and they have a student's average grade. And note that these are both on a ratio level of measurement. You could have 0 for family income, and you could have a 0 for your average grade. The scores can be shown in a scatter plot. So here's a scatter plot showing those grades. Each dot represents one participant. And here we would use a correlational analysis and get a correlation coefficient. You're looking for a relationship or an association between the variables. Here there is no cause and effect. Now, if both variables are non-numerical, success rate, succeed and fail, college graduate, no college graduate, so there's no actual numbers, it's just a yes or no type of thing, you would evaluate by organizing the data in a matrix. You categorize, categories of one variable form the rows, so this is one variable. Categories of the other variable form the column, so this is another variable. And you apply the chi-squared test. So hopefully you're seeing if you have that nominal or ordinal level of measurement, you're not going to be doing an ANOVA or a t-test. So it's important when you're looking at different examples and different designs or trying to decide what type of analysis to do for your own research, you look and see what level of measurement am I using, what type of design am I using, how many groups do I have, do I have one group of participants participating in all of the conditions, or do I have separate group participants? And I hope that was a good review for you for statistics and that you will be successful on the statistics assessment. I also have some examples in a separate video that I will post as well.